Okay, equations. Now, you might see something like 2x plus 3. That's not an equation, that's just an expression because there's no equal sign. Okay, it's just an expression. However, an equation has an equal sign. So something like 2x plus 3 equals 5, that's an equation. And it's very important in algebra to be able to rearrange equations. So let's do an example. Let's start off with a equals 4b plus 5. Okay, a equals 4b plus 5. Right, there's an equal sign, so this is an equation. You might be asked to do something like make b the subject of this equation. What does that mean? Well, at the moment, a is the subject of this equation. That means it's in the form a equals something. Okay? A is on one side of the equal sign by itself, and everything else is on the other side of the equal sign. And we have to make b the subject of this equation, which means we have to rearrange it to get it in the form b equals something. Now with equations, you can rearrange them and do whatever you like to them. You can change their structure and their form. It's still the same equation, just in a different form. As long as whatever you do to one side, you do to the other. You can do whatever you like to this side as long as you do the same thing to the other side. That's the law. So, what I'm going to do to both sides, to make b, to start off with, to make b the subject, I'm going to subtract 5 from both sides like this. Okay? Whatever I've done to that side, I've also done to that side. Okay? So what do we get? Well, on this side, we get a minus 5. Okay? Now on this side, we've got 4b plus 5 minus 5. Now the reason I chose to subtract 5 from both sides was because plus 5 and minus 5 is 0. So you can cancel them. But we're just left with 4b on that side. Okay? We've rearranged it. We've changed the form. We've now got a minus 5 equals 4b, which is the same equation, just in a different form. Now, we're not finished yet. We have to get b by itself. At the moment, it's 4b, and we need to turn that into just b. So what are we going to do to both sides? If we divide both sides by 4, it'll get rid of that 4. Watch this. We're going to divide everything by 4. That means get the line underneath both the a and the 5. And same on this side. Divide everything by 4. Okay? So, that side doesn't change. That's as simple as it gets. Okay? Now, on this side, we've got b times 4 divided by 4. So 4 on the top, 4 on the bottom, they cancel. And you're just left with b. Okay? We've done it. We've made b the subject of the equation. It's now in the form b equals something. And it doesn't matter which way round you write it. So I'm going to rewrite it as b equals a minus 5 over 4. Okay? And that's it. That is the same equation as that, just written in a different form. And that's how you rearrange equations. And we made b the subject in this case. Right, let's do another example. Right, let's do x equals y over 3 minus 7. Okay, x is y over 3 minus 7. Notice that the 3 is only dividing the y. It's not dividing the 7 as well. unlike this, the 4 is dividing both the a and the 5. Okay, we're going to rearrange this to make y the subject. Okay, so firstly, let's take the 7 over to this side. Our objective is to get all of this junk away from the y on the other side so the y is left by itself. So we'll start with the 7. And to do that, we're going to add 7 to both sides. Okay? So what do we get? X plus 7 on that side. On this side, minus 7 plus 7 is 0. They cancel. Okay? We're just left with y over 3. Like that. Good. Now, we've got y over 3, and we want y. So if we multiply both sides by 3, it'll turn that into just y. So that's what we're going to do. Now, when multiplying, as opposed to subtracting or adding, you have to multiply every single term. So I'm going to write times 3 underneath the x and underneath the 7. Okay? And underneath this one. So we're multiplying every single term by 3. So what do we get? X times 3 is 3x. 7 times 3 is 21. And y divided by 3 times 3 is just y. Okay? Because divided by 3 times 3, they cancel. So you're left with just y. The way I've written it there, if you like, you can go off to the side and do it like this. You've got y over 3 times 3. So 3y over 3, which is just y. Okay? But that's just another way of looking at it. So we've done it. We've made y the subject. Y equals 3x plus 21. Same equation, different form. Okay, good. Let's do another one. M equals root n plus 2. Why not? M equals the square root of n plus 2. We're going to make n the subject. Notice that the square root is only rooting the n, not the 2. It doesn't extend all the way over here. Okay, so got to make n the subject, so we want the 2 over here. So let's subtract 2 from both sides. n minus 2 on that side, plus 2 minus 2, cancel. We're left with just the square root of n on that side. Okay? Right. We want n by itself, but at the moment we've got the square root of n. So we want to do the opposite of whatever the square root is. And the opposite of square root is squaring. So to turn that into n, we're going to square both sides. Right? Which means, I'll write it again on this line, okay? We're squaring the whole lot. Like that, okay? That's correct. You can't just work along and square each individual term. We're squaring the whole of that side, which happens to be root n, which means we have to square the whole of this side. So you have to introduce brackets yourself, like I have, and the square goes outside those brackets to square the whole lot. Okay? It's very important. It would be wrong, okay, if you've got m minus 2 equals root n, it would be wrong to do this, to say, okay, well, therefore, we'll just square everything. M squared minus 2 squared would be plus 4 equals square root of n squared is n. That's wrong, okay? You can't just move along each term and square them, okay? So, not like that. You have to square the whole thing. Anyway, what have we got? Well, n minus 2 squared. I'm just going to leave it like that. Nothing wrong with that. It's as simple as it gets. Equals the square root of n, all squared, is just n. You square root something, and then you square that, you're back to where you started, which is n. So what I'm saying is that the square root of n times the square root of n is just n. Yeah? For example, what if n was 25, say? The square root of 25 times the square root of 25, I'm claiming that that's 25. Yeah? Well, I'm saying square root of 25 times square root of 25 is 25. And I'm right, because square root of 25 is 5. So it's 5 times 5 is 25. So I hope I've convinced you that the square root of n squared is just n. So, we've done it. We've made n the subject. We've gone from there to there. So our final answer is n is n minus 2 all squared. Brilliant. Okay, let's do a couple more examples. Let's do u equals w plus 2 over 5. All over 5. So the 5 is dividing the w and the 2. Okay, so we've got a 5 on the bottom there. So let's multiply both sides by 5, and then we'll have everything on the top. We're making w the subject, by the way. Okay, so multiply everything by 5. So we're going to times that by 5. So how are we going to write this whole thing multiplied by 5? I suggest putting it in brackets and doing a times 5 there. Okay? Remember, we're multiplying this whole left-hand side by 5, so we have to multiply the whole of the right-hand side by 5. In which case, you have to introduce your own brackets and write times 5 there. Good, so what do we get? We get u times 5 is 5u. Okay? Now we've got this whole thing, well, w plus 2, all divided by 5, all times by 5. So as usual, we can cancel the 5s. And we're left with just w plus 2. I could write that in brackets if you want, but it's fine just like that. Okay, so we want to get the 2 over here, and then we've got the w by itself. So let's subtract 2 from both sides. And we get 5u minus 2 is 5u minus 2. W plus 2 minus 2 is w. We've done it. W equals 5u minus 2. There you go. That's that rearranged to make w the subject. Right. I just want to talk about this a little bit more. What we did, we had w plus 2 all over 5, all multiplied by 5. Okay? When I cancel those 5s, what I'm really doing is saying that 5 goes into 5. 5 goes into 5 once, and 5 goes into 5 once. So what we're left with is w plus 2 all over 1 times 1, okay? Which is the same as anything times 1 is just itself, which is the same as w plus 2 all over 1. Okay? Now anything divided by 1 is just itself. So there's no other term, so we can remove the brackets. So w plus 2 over 1 is the same as just w plus 2. Okay? And that's why I went straight from that to just w plus 2. So what I'm saying is that anything, okay, let's say x, anything times 1 is just the same thing, all right? X times 1 is x. I'm also saying that x divided by 1 is just x. Okay? So when you multiply something by 1 or divide it by 1, you don't do anything. You're back to where you started. Good. Right. Final example. Let's do x squared minus 4 over 3, x squared minus 4 all over 3, plus 5 separately, not divided by 3, equals y. Okay? And we're going to make x the subject. Okay. So what should we do first? Well, we want to get x by itself, which means we want to get the 5 on this side. So it's plus 5 there. So let's subtract 5 from both sides. Okay? Now, I'm going to introduce a bit of new notation here. And it's therefore, which is 3 dots. So you say therefore, if that, therefore, this hasn't been affected, it's just x squared minus 4 over 3, okay, plus 5 minus 5, cancel, equals y minus 5. Okay? What a lot of people do is that they write an equals there. You've got x squared minus 4 plus 5 equals y equals x squared minus 4 over 3 equals y minus 5. Don't do that. It's not technically correct, because what you're claiming, if you write that as an equals, is that x squared minus 4 plus 5 equals that, which is also equal, if that were an equals, to x squared minus 4 over 3. And x squared minus 4 over 3 plus 5 is not equal to x squared minus 4 over 3. Okay? You've got an equation there, right? Just write, therefore, put the equals underneath the original one, and then whatever you get when you rearrange. That is correct. That's the way to do it. Anyway, moving on. Right, we've got to make x the subject. So, we've got a 3 on the bottom. Let's get rid of that. So, let's multiply both sides by 3. So, I'm going to write it like this. Same as over there. Multiply the whole lot by 3, which means introduce your own brackets. Don't be shy about introducing your own brackets. We've got to do it on this side as well, because we don't just have a single term. We can't just write times 3. If I wrote times 3 there like that, it's wrong, because only the minus 5 is being multiplied by the times 3. You've got to have the confidence to introduce your own brackets. Okay? So, if that, therefore, dot, 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 x squared minus 4 divided by 3 times 3 is just x squared minus 4. Okay? Equals multiplying out brackets. We've got a 3 times every term inside the bracket. So we've got to do y times 3 and minus 5 times 3. So y times 3 is 3y. Minus 5 times 3 is minus 15. Okay? So next, we've got to make x squared the subject, which means getting the minus 4 over here. So therefore, what are we going to do to both sides? We're going to add 4. Okay? So therefore, we get x squared minus 4 plus 4 is gone. We get x squared equals 3y minus 15 plus 4. Now, before we do anything else to either side, we're going to neaten that up by gathering like terms, because we've got a minus 15 and a plus 4. Minus 15 plus 4 is minus 11. Okay, we're nearly there. We've got an x squared. We need to turn that into an x. So what's the opposite of squaring? Square rooting. So we're going to take the square root of both sides. You have to square root the whole thing on the right because we've square rooted the whole thing on the left. Okay? So therefore, x squared, square rooted, squaring is the opposite of square root, so it's just x, equals, and that's it. X is the square root of 3y minus 11. And we've made x the subject of that equation. There you go.